Now, in this part of discussion, now we will be focusing on ANCOVA only. So you can compare ANOVA and ANCOVA by comparing the discussion in this session and the discussion which we have done in the previous session. Well, now what is ANCOVA now? Now we are now moving towards ANCOVA. Univariate. In the univariate, now the additional variable as a covariate has been added in order to change the status of ANOVA to ANCOVA. Now, you see, as we select the covariate, a number of items, if you want to see the features of this variable, so this it is actually a continuous variable, or you can also see it from the actual data file, the item, for example, control T, what is mentioned under the item, let's see. So these are the number of items purchased. So number of items is a continuous variable, which we are considering as a covariate. So this is how we have shifted. Now the post hoc, you know, it becomes redundant. It becomes irrelevant here when we are discussing ANCOVA. So ANCOVA is actually ANCOVA relates three variables, more than three variables. It can be, there can be one fixed factor variable, or there can be more than one, which actually complicates the ANCOVA. So factorial ANCOVA and so on. That we will be discussing a little later on. So now in the options, all other things as usual, but the only difference in ANCOVA, you need to estimate the parameters, the coefficient, the slope parameter. Why? Because now you have added one variable in the list as a new independent variable, which is considered as a covariate. So actually, when you select this, you want to see the effect of changing effect of that covariate on the dependent variable, which means spending. So as we want to see, as the number of items increases or decreases, then what is the effect on our expenditures, average expenditures. So this is how we are going to analyze. Well, the other options, as usual, overall is selected. And now here, since you have more than two categories of the fixed factor card, because card are of 5 types. So then in order to compare, instead of having post hoc, the substitute for post hoc in ANCOVA is Bonferroni. In Bonferroni, if you select it, this will compare the average expenditures against different types of cards, credit cards we are dealing with in this example. So we continue. Now save, if you want to save, for example, unstandardized predicted value, or this can be, according to the regression definition, it is mu hat, y minus y hat. So y minus y hat is here, unstandardized mu, and this is actually y hat. And if you want to save the standardized value, which means converted unstandardized to z, so standardized. So this is how you can save. Why we are saving, I will explain it a little later on. The plots which you want to see, yes, we want to see credit card. We want to see the relationship of the variables against each category of card. So add, then continue. Other thing, contrast not needed here because we are keeping it simple. Okay, we click OK. Yes, model can also be done, but I will explain it a little later on. There are certain criteria on the basis of which we have to make the model. Okay. Now these are the results. These are the total results. What does that show? We start from here. Our results actually start from here. The univariate analysis of variance. Now look, the information about the categorical variable. The categorical variable has 5 categories. Their sample size is very important. For example, if the Levine test, if the Levine test shows significance of the variances, which means heteroscedasticity. So in case of heteroscedasticity, the results are only robust if this sample size of different categories do not differ from each other much. They are approximately equal. Excuse me. So if there is not much difference in the sample size of these cards, then the robustness can be ensured. Descriptive stats, they show unadjusted mean value of the expenditures against each card. For example, expenditure against this credit card, this Visa, MasterCard, Discover, other, and this is overall 196 is the total average. So average expenditures are higher on 236, they are higher on American Express card. So whether they are statistically significant or not, that we discuss here. So Levine test shows, it is significant, so heteroscedasticity. So if there is heteroscedasticity, then we apply further, test of further diagnostic test, and we ensure the robustness of the test. So यहाँ पे, test between this table actually indicates, the items, the number of items significantly affect the amount of expenditures. Why? Because the probability of this F value is much less than 5%. It is rather less than 1%. So we are compelled to reject the null hypothesis that items do not cause overall expenditures, but we reject and we conclude that if number of items increase or decrease, it does affect the overall expenditures against credit cards. Partial eta squared, again, it measures the size of the effect size. It is much higher than the Cohen's conventions criteria, Cohen's guidelines, wherein the size of the effect is big if eta square is more than 14%, though the guidelines are 1%, 6%, 14%, small, medium, large effect. So it is much higher than 14%, rather it is how much? It is 75.4%. Similarly, items and card, across different types of cards, the expenditures significantly differ. And the effect size is 1.5%, which actually is near to small sized effect. So the size of effect is small in case of card. The card, type of card or the card variable does affect expenditure, but the effect size is relatively small. Now coming to the parameters estimates, as usual, as we explain the relationship of dependent and independent variables for regression analysis, it is the same. So almost all the categories significantly affect the expenditures, positively, negatively, positively. But the way of interpretation will be different. For example, in case of items, which is a continuous variable, we say positive relationship indicates that if the number of items increase by 1 unit, the total expenditures on the average increase by 69.96 US dollar, because the amount is converted to US dollars. How it is significant? Because the probability is less than 5%. The level of significance is much less than 5%. And other thing, as usual, the partial eta square 75.4, it must match with this value as we discussed above. So the effect size is much higher and bigger. And the power of the test is also excellent because it is much higher than 80%, which is the guideline. Now, as far as the categorical variable is concerned, how this relationship is explained. For example, credit card number 1, 2, 3, 4, all these have positive sign. So this is number 1. So if they each of them has positive sign, it means the reference category, which is card number 5. So as compared to card number 5, the expenditures, the average expenditures on each of these cards is significantly higher. The average expenditures on these cards, each of these cards is significantly higher than the average expenditures on the card number 5 because it is positive. So if it were negative, then we would have explained it the otherwise. So यहाँ पे आप देखें तो average expenditures on card number 1 are $40.8 higher than the average expenditures on card number 5. इसी तरह similarly, the average expenditures on card number 2 are $27.72 higher than the average expenditures of card number 5, and so on. So for just $4.3 higher, 3 on third card, $20 higher than fifth, and so on. So, but the card number 4, you see, not only the value is relatively smaller than the other cards' average expenditures, but it is also proves statistically that it is not significant. So it is not significant. So the expenditures on card number 4 and 5, they are not significantly different from each other. This is known from here. Now the effect size can be shown here. The effect size is not much higher for card number 4. The effect size is not higher. It is even, just less than small effect, which is 1%. So it is even less than 1%, less than 1%, 1%, and so on. But the highest size is in case of number of items. So this is the key determinant. And then, SPSS gives you this mean value twice. What is the difference? This is unadjusted average expenditure. This table shows unadjusted expenditures. And this shows adjusted average expenditure. Adjustment, when I say adjusted, what does that mean? It means adjusted for the covariate, for the effect of covariate. What does that mean? The average expenditures against each category of the categorical variable, which is independent variable, given the effect of which is adjusted from the covariate, the third variable. So this is actually the covariate, the grand mean adjusted. It is different from the unadjusted value mentioned above. Similarly, primary card average expenditures are, they are also adjusted. And the adjustment is mentioned here. You see the number of items 2.36, it is adjusted for this value. So all these items. And then, as usual, Bonferroni Test simply compares the average expenditures on each card against every other card. For example, American Express compared with the 4 cards. Positive means the average expenditures on American cards are higher than that against Visa, MasterCard, Discover, and others. So if it is negative, for example, here, then Visa, the expenditures on American Express are higher than the average expenditures on Visa.